In this video, I'm going to show you how to do Chapter 2, numbers 43, 45, and 49. This is question number 43. So there's a couple important pieces of information in the question. The goal is to figure out the charge of the electron in this imaginary universe, and we are given the following charges. So we can assume that the different drops have different numbers of electrons because the charges are different. However, the charge of an electron is always constant. So what we're going to do is first we're going to just find the difference between two charges. So between drop A and drop D, those are the two lowest charges. If I find the difference between them, I get a charge of negative 2.3 times 10 to the negative 19. Okay, so let's say drop D had 2 electrons, and if we added one more electron during drop A, then the charge would increase by negative 2.3 times 10 to the negative 19. But let's see if that's consistent. So when we look between drop A and B, this also has a difference of negative 2.3 times 10 to the negative 19. And when we look between drops B and C, this also has a difference of negative 2.3 times 10 to the negative 19. So since the difference between each drop is a factor of this number, we can add a factor of that number to the drops. This is going to be the charge of the electron in this imaginary universe. Please feel free to leave a comment if that doesn't make sense, and I'll try and do a better job of explaining it. Number 45 says, on a dry day, your body can accumulate static charge from walking across a carpet or brushing your hair. If your body develops a charge of negative 15 microcoulombs, remember that little symbol means micro, and micro is 10 to the negative 6. How many excess electrons has it acquired? What is their collective mass? The way I solved this problem is I started with the second question. I started by calculating the mass. So I know I'm given negative 15 microcoulombs, and that means negative 15 times 10 to the negative 6 coulombs. And I know, based on what the textbook has given me, that one electron has, we can do the first question first. One electron has a charge of negative 1.6 times 10 to the negative 19. So the question is, how many electrons does it have? How many excess electrons? So when I multiply this across and divide by the denominator, I got 9.4 times 10 to the 13th, that should be a 13, electrons. Okay, so that's how many extra electrons it has, and this is in coulombs. So just going back to the stoichiometry part of it, the coulombs cancel out, so I'm left with the unit of electrons, which is what I want in my answer. So now I'm looking for their collective mass. So if I have 9.4 times 10 to the 13 electrons, and from the book, I know that one electron has a mass of 9.1 times 10 to the negative 28 grams, then my electrons are going to cancel out. I will be left with grams, and their collective mass should be 8.53, oops, that is a bad 5, 8.53 times 10 to the negative 14 grams. Okay, so this answer should be bigger than 1 because it should be a larger number than the mass of one electron because we have more than one electron. But it's still a pretty small number because electrons are tiny. Lastly, number 49 asked how many electrons would it take to equal the mass of a proton. So, the book shows this great table at the bottom. And so when we're looking at the number of electrons that would be equal to the mass of a proton, we are looking at our mass column. And the mass of a proton, and you can choose to do mass in kilograms or in AMUs. I'm going to do the mass let's do the mass in kilograms. We're looking at our mass column. So if we have one proton has this mass and one electron has this mass, to figure out how many electrons are per mass of the proton, all we're going to do is we're going to take the mass of one proton and we will divide it by the mass of one electron. So the top number is the mass of a proton, the bottom number is the mass of an electron, and so we would get this many electrons are equal to the mass of one proton. So notice, electrons are much, much smaller than protons, so when we calculate the mass of an atom, we don't even take into account the electrons, because we would need 1,838 electrons just to equal one proton.